I welcome you all. Myself Nagarajan, Assistant Professor in EC Department, Rohini College of Engineering and Technology. Here we will discuss about the Control System Engineering EC 8391 Unit 2 analysis. Okay, so in this slide we will discuss about the time response analysis. First of all, we want to define that is a time response. Time response means the time response of the system is the output of the closed loop system as a function of time. That means when we consider any system, that is the output is depend upon the time. So that is a time response. So time response definition, that is the time response of the system is the output of the closed loop system as a function of the time. So it is denoted by C of t. Sometimes they will denoted as a C of t and like that. So the basic definition, time is used as a independent variable is most control system. It is usually of interest to evaluate the system response with respect to time. So time response of the system is the output of the closed loop system as a function of a time. So when we consider any system, it is a function of a time, means that system is considered as a time response system. Okay, so it can be represented as a C of t. So the response given by the system, which is a function of time to the applied excitation, is called the time response of the control system. So time response of control system means any system, the output of a closed loop system as a function of time means it is a time response system. And we will see about the typical input signal. That means the knowledge of the input signal is required to predict the response of the system. We need to predict the response of the system, so we need some tested signal, standard tested signal. So standard tested signals are, first one is the impulse signals, and second one is a step signals, third one is a ramp signal, and fourth one is a parabolic signal. These standard test signals are used to predict the response of the system. So these are the standard test signals: impulse signal, step signal, ramp signal, parabolic signal. These are the standard test. Now we will see about the step signal. So in typical input signals, first one is a step signals. The step signal is a signal whose value changes from 0 at a, that means t is equal to 0. When the time t is equal to 0, it has some value, the constant value, that is a step input signal. Okay, it has some constant value. This is a unit step input signal. Unit step input signal. The step signal is a signal whose value changes from 0 to a at t is equal to 0. The remaining values are 0. Remaining values are constant. So when a t is equal to 0, after that it has some constant value. T is equal to 0 and t greater than or equal to 0, it has some constant value. These are the unit step signal. So t greater than 0, it has a value is a 1. Otherwise it has a 0 value. That is a step input. And next one is a ramp signal. Ramp signal means whose value increases linearly with time from the initial value of 0 at t is equal to 0. When the t is equal to 0, it is increasing the value linearly with time. When the time is increases, it also increases the response. So this is a unit ramp input signal. It can be represented as a t greater than or equal to 0, it has some value, that is a response 0, otherwise it is a 0. This is a ramp in. And next one is a parabolic signal. That instantaneous value varies as a square of the time from initial value of 0 at t is equal to 0. That means it is a square of the varies as a square of the time from the initial value. So it can be represented as like that. This is the frequency response, time response of the parabolic input signal. Next, these are the standard test signal. We can represent it in a mathematically. This is the input signal. It can be represented as R of t. Next, it is a Laplace transform representation. This is the time response representation R of t. This is the Laplace transform representation capital R of s. That is the input response we are considering as A. It is a Laplace transformation is a by S. A ramp input is a of t. It is can be represented in a Laplace transformation A by S square, and parabolic input is a t square divided by 2. Here is a divided by S cube, and impulse input it is a del t. It is really a 1. Next, in second unit we will discuss about the that is a time response analysis. Time response means that is a system output is a depend upon the function of a time. So it can be divided into two types. So classification of time response. First one is a transient response and another one is a steady state response. The total time response is a y of t is equal to transient response plus steady state response. So classification on time response, that is a time response can be classified into two. One is a transient response, another one is a steady state response. So now we will see about the transient response. That is a transient response means is defined as a part of the time response that goes to zero as time becomes very large. That means time when the time response goes to zero, at the time that is a time becomes a very large. It can be represented as a y of t that is a time response, transient response y t of t is equal to 0 when the time goes to a very large. So this is a time response representation, and the time required to achieve the final value is called transient period. The transient response may be exponential or oscillatory in nature. So the time required to achieve the final value is called transient period. The transient response may be exponential or oscillatory in nature. And next we will see about the steady state response. So after remaining response we are after the transient response we are considered as a steady state response. So steady state response is a part of the total response that remains after the transient has died out. Okay. So in a control system position, the steady state response when compared to with the decided response position gives an indication of the final accuracy of the system. So it is creating a error. So we want to define a steady state error. That is, if the steady state response of this output does not agree with the decided reference exactly, the system is said to be a steady state error. That means the steady state response of the output does not agree with the decided reference exactly. So this is a steady state error. Okay, thank you.